Hey, what's up, guys? So for this video, I'm going to give people who are running on a Mac or Linux some help in getting a CMake project generated for CS-210, considering there is no guide provided as there is for Visual Studio. So just before we begin, I forgot to mention in my initial recording is that if you need any support throughout this course or any other courses during your computer science degree, head on over to our Discord linked down below. Yeah, it's currently got 600, 700-ish members and counting, filled with CS, cybersecurity, IT, and math nerds, all from SNHU doing their degrees or alums that have already completed theirs. We are currently running a game jam that goes until the end of January. So if you're interested in that as well, there's always time to sign up for that. We're giving away t-shirts to anybody who makes a submission. Let's get back to the lesson. To begin with, if you look at the Python combining C++ and Python rubric, they give you a C++ and Python Visual Studio guide, which basically explains to you how to do it step by step anyway. I'm going to do that, but I'm not going to solve the actual, I'm not going to output the same thing. I'm going to let you do your own thing, right? First thing we're going to do is I'm going to be using CLion as my CMake editor. You can use any CMake compatible editor you like. Some people like Visual Studio Code, while others might like something else. I prefer CLion. You can get a free educational license over, I think it's jetbrains.com/education or something. Yeah, you can do that, and you can apply for your educational project or free access to professional tools using your SNHU EDU email. So I'm going to use CLion, so let's open CLion up. So when you open CLion for the first time, you're going to get a screen like this after you select your dark mode settings and stuff like that. What we're going to do is we're going to create a new project. I'm going to make it a C++20 project, and the folder I'm going to put it in is 2.1. And that's the name of my project, 2.1. I'm going to create that. Now, CMake is going to generate a Hello World folder project for you, and all this is going to do, if we run it, you'll see it'll compile and it'll run Hello World inside your terminal. So there's a few things we need to do. The first thing we're going to need to do is expand our CMake list file to include Python. To do that, we're going to do a few things. So we're going to expand our CMake list file to automatically bring in the version of Python you have on your computer. So if you look, if I look here and I look here, I have access to Python here, and I think it's just quit that, and I think I can do Python that version. So you have access to Python 3.9.7. So that's what I'm going to be bringing in, and that's what you can do as well. You might have it installed. If you don't have Python installed, basically, if you don't have Python installed, you can install it yourself. I personally install my Python installation using PyCharm, which is another JetBrains tool, but you can install it any way you want, and just make sure that you have Python on your path, because very likely that's having it on your path is going to be enough to get it working. So let's get into this. So the first thing I'm going to do is I'm going to add a, right now, if we build it, you'll notice that we have our executable inside the CMake build debug folder. I don't like it there. I like getting it generated outside. So we're going to put it in a distribution folder. So let's say we want it like here. There's going to be like a distribution, and then there's going to be a platform. And here, I think it's going to be called Darwin. And then it'll land underneath there. So that's the first thing we're going to do. So to do that, what we need to do is we're going to set our output directory to CMake source-dir to/dist/ and CMake system name. Now this is an optional step. This is going to create an environment variable called output dir, which is going to hold the directory we want to output our project to. This line here is sets it to standard 20 or C++ 2020. Likely for the class you might need C++ 11 like that. So the next one we're going to do is we're actually going to set that CMake variable. So we're going to set CMake runtime output directory, and we are just going to use our output dir variable here. Now the reason we do that separately is because if there are going to be things that we want to bring into this output directory with our executable, and that's going to be necessary, we're going to need access to the output dir. So the next thing we're going to do is we're actually going to bring in Python. So to bring in Python, the Python interpreter, which is what's going to actually run your Python code, you'll do find package. You'll then do Python 3. You'll say it's required, and you'll want a couple of components from it. Specifically, you'll want the interpreter and the development components. Then for add executable here, I don't like hard coding it here. I like switching it to project name. So it'll reference this this name here, and that's just so that I can use this everywhere, and if I want to change the project name at any point, I just change it up here and it changes everywhere. So that is pretty much all we need to bring in Python to find the package. So first let's reload and see what it tells us. We reload. If we go to CMake tab down here and we hit this reload CMake project, you'll see that nothing has gone wrong, which means that we have found the components required. So I'll show you how you can use this for other packages. So let's say you want to add Python. You would look at, you know that it's supported somewhat natively by CMake. So let's just say you do find package Python, right? And make sure to put CMake at the end, and you'll find this, find Python. If you look here, you're going to find a bunch of variables. First thing is Python found. Now this will return true if it finds the Python thing. The only problem you might have is if you look here, if you put required here, you don't really need to check that Python found here. But if Python is optional, you don't put required, and you would do something, I think it's something like if it would be Python found or something like that. And then you could say, and if it would be like, I think it's not, I don't know. I don't remember the syntax for if statements. We're not doing that. But you do something like that. You do an if statement, and then you would and then you would print a message Python not found or something like that. So let's go back to there. You'll see all these variables here. Now, to bring in Python, we're going to need a few things. We're going to need the header files, which you have learned about, which are usually in a variable called Python 3. Let's not just look for Python, look for Python 3. So we're looking for Python 3. So if you look, now we look here, you're going to see a Python 3 include dirs. So your include directories are what contains all your header files. So we're going to need that. And we're also going to need the libraries to link against, which is how the compiler, so there's multiple compile steps. There's going to be, it's going to get all your headers, make sure everything makes sense semantically, and then the linker will take all your different libraries and packages and make sure they all reference each other properly to output your final executable. So you also need the libraries here to do that linking step. Make sense? So we're going to do that. Now to add these things to your project, we're going to use modern CMake functions. Specifically, we're going to include the headers, the include directories. We're going to do target include directories. So when you create an executable in CMake or you create a library, you are creating what CMake refers to as a target. Now your target, the first parameter in the function is your target name. So when you're creating your when you're adding the target include directories, you have to give it the target that you want to include the directories in, which is going to be your target, so project name. Then you're going to want to set, you're going to actually want to set your target, your include directories. To do so, you need to specify whether or not these header files, in this case with the include directories, these header files are private to this CMake package, or whether or not, if this package is imported into another CMake project, whether that other CMake project would be able to see those headers. Now, in our case, using the practice of making things as least accessible as possible to the outside world, we're going to assume that everything right now is private unless we find a need to do otherwise. So we're going to say it's private, and then we're going to include our include directories. And if you remember, we have this Python 3 include directories variable that we can paste into here, and there we go. And that's how you would include the .h files. Now, if you look at, so we're going to do this step by step. So now we've got the header files. So how do we prove that? How do we make sure that we actually have that using CMake? So first, we're going to find the sample code that is provided for this assignment somewhere. Now we just need to find it. Is it here? Download Python, blah, 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 blah. Here, no, this just says to run it, to build it yourself. So here, we've got an include directory in this guide. I'm using the Visual Studio Guide as a guideline, but you see include python.h. So in theory, we should be able now to go into our main.cpp, and we should be able to include python.h. And you see here, it found python.h fine. Now, if we didn't have that, let's comment this out. Reload our CMake project, and if we look in here, it's going to tell us it can't find python.h. That's how you can verify that what you're doing is sane, that the steps are being done properly. So with the include directories done, now I'll show you what happens. So you've got here, we've got this initialize function here. This is the first Python function to be called. So let's remove our hello world, and let's just put the initialize. Now, if I know my C++ as well as I think I do, when I build this, you're going to see linking error here, and it's saying unreferenced symbol initialize in main.cpp. So what it's saying is that even though you have semantically, you have declared the existence of the function initialize here. So you see here, this is just a function declaration. The library for it, which is the actual implementation, is not found by the linker, which means that you can't compile your project. Now that is where I told you that these Python libraries come into play. So let's start with that. So we go back to our CMake list file, and very similar to this target include directories, there's also a target include target link libraries. So this, as the name implies, is libraries that you're providing to your linker so that when you link it at compile time, it can find everything you need. As the first one, you need to specify your target name, which in our case is our project name. And just like before, you need to give it its accessibility parameter, which we will always use private unless otherwise, but unless there's a need otherwise. And we will put Python 3 libraries. So now we'll reload those changes. You'll see here, CMake reloads the changes. Let's do this here. We reload the changes. Everything's working well. And then when we go into our main.cpp and we build this, build finished, everything links okay. Now we might run into an error. Let's just run it and see what it tells us. Process exit with code 0, and that's exactly what we want. So let's follow this guide and add a Python module. So the first thing we want to do, we want to import a module, right? So let's just start with this, and we're going to name it ourselves. This is what we're going to do. So we want to create a new module, and we're just going to call this my module like this. My module. Now, how does that work? So just as in when, just like when you would be working with Python, it's going to look so inside the runtime directory for all your modules. So your runtime directory is wherever your executable is, which is why we pulled it out of CMake build here. So if I remove this here, if I delete this file, you're going to see if I build now, it doesn't show up here because we've specified it in dist, Darwin, and you see 2.1. Now we want to put our Python code inside our distribution folder, but we want to make this as cross-platform as possible so that wherever your instructor is running this, it's going to work. Now Windows is a little bit different. There's a little hacky code snippet we're going to add to make it work on Windows, but we're not worried about Windows right now. So for example, let's say we would prefer to have a directory here. Just for organization, we create a directory here, and we'll call this Python modules, right? So, and then inside here, we are going to create a Python file, and we'll call this mymodule.py. And we want to access this py file. And then let's use the sample Python that was here. Where is it? Here. We want to use this sample Python code. Hello from Python. Right? So we want to define these things here. So what you can do here in CLion, you can configure your Python interpreter so that your Python will work directly in CLion. So here it shows no interpreter. If I hit show all, it will find the Python interpreter from somewhere else in my on my computer. Hit OK. Hit apply on that, and you'll see now everything loads properly. And now you have access to Python linting, where you can do here, and you see here it tells you everything you want to put inside. So it gives you proper autocomplete, and you have access to C++ inside the same editor, which is one of the reasons I prefer CLion and JetBrains. So we have that Python module here, right? So this is called my module, and we want to print something. So let's continue down with this code. So let's just get to the function where it says here. So first we will print the if there was a Python error. And again, I am doing things, so you have to do some of this yourself. I'm not doing everything for you. And then we want to print something from my module, right? So, right. So this should be, and there's one more. We actually want to call the function. So we call the function and we finalize the thing, right? Now you can add more statements in here. We're just going to do this like this. Now, if I run this, it will probably give you an error. So let's run this. What does this tell you? No module named my module. Now this is probably being printed right here, right? So exit code 139. It's probably py print. So let's go here and I hit the debug. Will it ever get there? It does get there. What does it show in the console? It does print module name my module. And then it goes here. And then it crashes because it's a bad access, right? So there's probably a way to check that. It doesn't really explain it in the guide. That's not what we're doing today. But now let's start giving access to my module. So the first thing we're going to do to just prove out what we need to do is to make sure that this works. What we can do is we can take this module and copy it directly to our distribution directory. So when we do this, you're going to see that it says no module named my module. And the reason this happens is because when we're running our application, it's not assuming that the current path, the current directory is on the Python path. So we need to add the current directory, the working directory of the application to the Python path. So to add the current working directory to our Python path, we're going to do a couple of things. First is we're going to make a pyrun simple string command, which is just going to run a Python command inside the current interpreter, which is initialized with PyInitialize, which we're going to import system. So we're going to import the system package. We are going to also import the OS package, and then we are going to add the current working directory to our current path. So this will be sys.path.append, and it'll be os.get cwd, get current working directory. And that's it. So that's all you need to do. Now, if we run this, you're going to see hello from Python. And that is being run from this specifically. Now we want to be able to import as many Python modules as we want, right? And not just the one Python module, and also we don't want to manually bring it over. So let's say we delete this. You're going to see that if we rebuild the project, which I need to make a change to the project and build, you're going to see that there's no Python files in here, and when we hit play, it's not going to find the module, right? So we need to make another change to our CMake list file. So let's go back to our CMake list, and we're going to add a custom command to it, which is going to copy our Python modules directory to our working directory. And that's the main reason why we had this separated out, to make it easier to keep track of. So we were going to add custom command. So it's going to be a command that works on a target. The target, like the others, is going to be project name. And it's going to be a pre-build command. So before the project builds, it's going to run a command, which is going to be a CMake command. And it's going to be a command copy directory. And this is going to copy the directory CMake source_dir. So the CMake source directory is the current project's CMake source directory where the CMake list is. So it's going to be this folder here. And then we're going to take the Python modules directory, and we are going to copy it to our output directory, output_dir /Python module. So let's reload that. And that's pretty much all we need to do. So let's reload that, and we will build the project. Now, if you build that, you'll see that it copied our Python modules into here. So if we try to run it now, you're going to see it still does not find our module, but that's because this is no longer in the root directory. To put it inside the root, to not put it inside the root directory, to reference it from our application, we're going to have to reference it like we would any other Python module, where we would have every directory is its own module. So it would be Python modules dot my module. And that's the same thing as if we were referencing from a Python file at the base directory. If we were referencing my module.py, this is how you would do it. So now if we run this, hello from Python. And that is how you integrate Python with CMake. But if you're working on Windows, what you want to do is you're going to need to copy over the DLL file, because Python, doing it this way, it doesn't provide the static library like it does with, well, it doesn't reference the Python directories libraries properly like it does on Mac and Linux. So we need to copy the DLL into the running directory. So you'll see that if you look here, you see it gives you, if I look DLL, you see here it says to find the DLL file from your Python installation and copy it into your running directory. In our case, we will do that manually. So we're going to add another custom command. It's another pre-build command, and this time it's going to be a little bit different. So we're going to do if CMake system name matches Windows, and we'll put an end if in here. We will say add custom command, target project name like we did before, pre-build, command, CMake command again, CMake command -E, copy, and then we are going to do things a little bit differently. So if you look here, inside find Python, you will find a function here, Python 3 runtime library directories. So runtime libraries is basically your DLL folder, where to find the runtime libraries. So let's we want to copy the DLL from that folder into our output directory here. So we will say Python 3 runtime library dirs. Then we will get the file. It starts with Python. Then we need the major number, which is Python 3 version major. And then we take the minor version, Python 3 version minor. Now, Python also has a patch version. Those don't get included inside the DLL name, so we ignore that. And we say .dll. And we just copy that straight into our output directory, like that. Now, that will make it so that this one CMake file that we have here will work on Mac, it should work on Linux, and it will work on Windows. And any of your instructors that use the CMake file should be able to run pretty much no problem, assuming that they have standard Python installations anyway. So with that done, we are now ready to, you are now ready to implement the rest of this C++ document and set up your rubric here. This will be important when you get to project 7, where you're actually going to need to have a fully working implementation of integration of Python into C++. So if you appreciate the effort that goes into making these videos to help you out through your educational journey, hit a like and probably subscribe. There's going to be more coming along specifically for this course and for other courses coming up in the future. We will definitely be looking into it further.